Hello, geometry. Welcome to lesson 10.5 on secant lines and segments. So we've talked a lot about circles in topic 10, so this is going to end our discussion on topic 10. We're going to introduce one more type of line called a secant, and in this lesson we're going to talk about different angles and segments formed in circles and how they interact with each other, and how we find their measures and lengths. First off, let's do a little review real fast. So again, if I draw a circle here, if I draw a line that intersects the circle at one point, just grazes this circle, right, intersects that point, this is called a tangent line. And we learned something about tangents and radii in, I think, lesson 10.1 when we talked about tangents, or 10.2. And then we talked about chords, right? So a chord, if you have a segment that intersects the circle at 2 points here and here, right, endpoints on the circle, then it's a chord. Now, I'll mention this in the next slide, but if we were to extend this chord beyond the circle, now we would get what's called a secant. All right, so there you go. So this is our new term today, secant. So you're going to see that we have the opportunity for a lot more intersection happening outside of the circle because we're going to go beyond the circle. All right, so let's take a look at our first slide today. All right, so this one says a secant is a line, ray, or segment that intersects the circle. So again, this word secant is our new word of the day. We have two secants, segment or line AC and line BD are secants here. So these two secants form angle 1. We want to know how can you use arc measures to find the measure of angle 1. Well, we're going to be clever here, right? We're going to create a triangle, and this is the triangle we're going to create. We're going to create a triangle right here by connecting B to A. So I create a triangle ABE, right? And now, angle 1 is an exterior angle to that triangle. We have this thing called the triangle exterior angle theorem, right? The theorem we learned in, I think, topic 4. This triangle exterior angle right here is going to be equal to the sum of its two remote interior angles. That is the angle here at A and the angle here at B. So we know that the measure of angle 1 is going to be equal to the sum of the measure of angle BAE, again, that's angle A, plus the measure of angle ABE. That's the angle at B. And again, this is the triangle exterior angle sum theorem. Okay, so now if we look at angle BAE, BAE has its vertex on the circle. It's an inscribed angle. So is angle ABE. B is on the circle, inscribed angle. So both of these are inscribed angles. We should know from lessons 10.4 that an inscribed angle is equal to half of its arc. So if we look at angle BAE, I'm going to trace BAE in blue, right? If I extend E, the side AE all the way to C, BC is the arc it intercepts. So the measure of angle BAE is going to be equal to half of the measure of arc BC. In purple, if I trace angle ABE, and again, it's going to be a lot of the same coloring, and if I extend BE all the way to D, then we see that angle ABE intercepts arc AD, so it's equal to half the measure of arc AD. So this is what the measure of angle 1 equals. The measure of angle 1 equals that. And if we factor out these 1/2s, we get this clever formula that the measure of angle 1 is equal to 1/2. We're going to put AD first, the measure of arc AD. The reason I do that is because that is the arc that AD, or that angle 1 opens up to, plus the measure of arc BC. And BC is the arc that its vertical angle opens up to. And this is a formula to find the measure of an angle formed by two chords or two secants inside of a circle. So we take a look at this slide here. This is your formula introduction. So the measure of an angle formed by two secants, again, secants, or it could be chords, that intersect inside the circle is equal to half the sum of the arcs. So again, here's angle 1. It opens up to arc X. Its vertical angle opens up to arc Y. We're going to add X and Y and take half of that. And again, here's your little interactive. I'm not going to take the time to go to Savas and do that, but again, if you take a look here, this is 130, this is 90, add those together, that's 220, and then take half of that, that's going to be 110, and there's your angle measure. All right, next, let's talk about another type of angle. Here we go. So what about the measure of an angle formed by two lines that intersect outside of the circle? So now we're going to look at these two secant rays, right? These are two secants, okay? Now they say two lines because we're going to see there's three cases. So this case right here is the two secants case, so two secants. So this angle is now outside of the circle. It's going to be half the difference of the arcs. So notice here, right, this angle 1 opens up to arc A, which is small, and arc B, which is bigger, because again, as the sides get longer, the space between gets longer, right? So what we're going to do here is we're going to take the larger arc B, subtract the smaller arc A, and then take half of that. So over here, if we do 95 minus 25, 95 minus 25 is 70. If we take half of that, that is 35 degrees. And that's your angle outside. Okay, so again, half the difference of the arcs. Two secants. And again, I won't take time to go online and do that. All right, next, the measure of an angle formed by two lines that intersect outside the circle is half the difference. Here, though, we have a secant and a tangent. So this is our secant tangent case. Secant tangent case, right? So here's the tangent, here's the secant. Now notice the two arcs here touch, right? So C and D are just kind of broken apart by this point right here, the tangent, the point of tangency. Notice that this arc right here, right, is the third arc that makes the circle. So if I look at this example here, right, you have a 60-degree arc, a 150-degree arc. You know what this arc's measure is because you know that 60 plus 150 plus you don't know, but you can find out, is going to equal 360. So remember, from this picture, you can find the remaining arc left over here. Okay? But again, it's still subtraction. So you take 150 minus 60. 150 minus 60 is 90 divided by 2, and that is 45. So again, still half the difference. This is your secant tangent case. And then last but not least, the third case. So now we have the two tangents case. So now if we have two tangent lines where they intersect outside the circle, again, that angle is equal to half the difference in the arcs. So again, these are my two tangents. So here, notice that E and F together make the circle. So E plus F is going to be 360. Now I'm going to show you a little shortcut, right? Again, so half the difference, right? But because of this, I'm going to claim that you don't have to know E and F. Watch this, right? So let's solve this for F, right? So let's subtract E on both sides. So F equals 360 minus E. And let's plug this in for F right there. So we're going to do 1/2 times 360 minus E minus C. Well, that's going to give us 1/2 times 360 minus 2E. If we now distribute that 1/2, we're going to get 180 minus E. And that is also what this measure of angle 3 equals. So this is a big, big, big idea. So the measure of angle 3 here equals 180 minus its closer arc, right there. And that's a way that if I know this outside angle, I know it's two tangents, I can easily find E and then use that to then find F. So if you look here, right, this closer arc is 180. So yes, we could do 260 minus 180, which is 260 minus 100, which is 160, and divide that by 2, which is 80. But you could also do 180 minus 100, and that's also 80. So again, a little trick of the trade there in terms of this two tangents problem. Okay, so there's all the formal introductions to these angle theorems. So now I'm going to stop this video, make a second video where we do some problems.